For this homework assignment, you were asked to do additional exercises on pages 215 and 216. Exercises C, problems 2, 3, 5, 6, 8, and 15. You were instructed to put these arguments into standard form and then determine validity using the Venn diagrams. Beginning with problem number 2. Amy must have done all of her studying at the last minute, for anyone who crams like that does poorly on the final exam, and Amy certainly did poorly. Now this is actually an example I used in the past. I can't recall if it was on your first exam or if it was just a problem I gave you in class, but at that time we looked at whether or not this was valid or invalid, and we used the method of counterexample in order to determine whether or not it was. What we're going to do here, though, is we're going to use Venn diagrams, and this is going to provide us another way to prove whether or not this is valid or invalid. But first thing we have to do is figure out the argument that's being made here, and then to put it into standard form, and then finally we can use the diagram. Now, the first thing we need to do is distill the argument, and we have to figure out the conclusion. And we notice here that we are given an indicator word, the word for. Whenever someone says, blah, 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 for, you know that what's coming next is the justification. If I say, all people are, terrible people, for, look at the sins they commit in the world, or whatever I say, I don't know, I couldn't think of a more creative example. But you know that what's coming next is going to be the justification. So for is a premise indicator word. Therefore, the conclusion must be the very first sentence. Amy must have done all of her studying at the last minute. Now, we need to put this into standard form. And in order to do that, we're going to have to make sure that we begin by using one of the 4 standard quantifiers, all, no, some not. And you might remember, you may not remember, how we do this when we have a proper name, or we name a singular thing. You may recall we talked about this when we studied propositions. We talked about singular propositions. And these are normally understood as universal quantifiers, which is kind of a weird thing. At first pass, it seems kind of weird. But the way we'd understand this sentence or put this into standard form is to say something like this. All people identical to Amy are people who do their studying at their last minute. Sorry, I got a typo there. All people identical with Amy are people who do all their studying at their last minute. And here we are naming a class, which is a class of 1. You can have a class of 1 object, people identical with Amy. And then we have our copula here, and then people who do their studying at the last minute, we have a class here. So this is in standard form. I know it sounds weird, and you may even, once you become more familiar with this, you don't always have to rewrite the sentences this way, just as long as you understand when you have a sentence like this, we are using a universal quantifier here to name a class. So this is how we typically do it. All right, now next thing we have to do is figure out what the major premise is. And in order to do that, we locate the major term, people who do all their studying at the last minute. So let's look up here and see if we see that phrase repeated, people who do their studying at the last minute. Amy must have done all her studying at the last minute, for anyone who crams like that does poorly on the final exam, and Amy certainly did poorly. Well, we don't see this wording exactly, but we do see anyone who crams. Now, studying at the last minute and cramming, those are the same thing. So this is going to be, I believe, the best candidate for what our major premise is going to be. Anyone who crams, cramming, studying at the last minute, those are the same thing. But this is going to need to be rewritten, because notice here we're not using one of the 4 standard quantifiers. We're using anyone. And notice also we're missing our copula. So we're going to have to rewrite this, and it's going to be something like this. All people who do all their studying at the last minute are people who do poorly on the final exam. Now notice that the major the major term here, people who do all their studying at the last minute, I left the word who out by accident, but people who do all their studying at the last minute, our major terms align now, and we're good on that score. We have our copula here, and then we have people who do poorly on the final exam. We name a class here. So this proposition is in standard form. This proposition is in standard form. The conclusion is. Now all we have to do is locate the minor premise. And the minor premise is going to be Amy certainly did poorly. But this is far from being in standard form. First of all, we don't have a universal quantifier. Secondly, we don't have a quantifier mentioned first. We're missing our copula, where we don't name classes in both the subject and the predicate term. So we have to fix this sentence in a lot of ways. And it's going to be something like this. All people identical to Amy are people who did poorly on the final exam. Now notice we have here the minor term, people identical to Amy, and everything seems to be aligned. We have our quantifier, we have a subject, in our subject term here, we have a class name, we have our copula, people who did poorly, we have, or maybe I should say people who do poorly. That's just a tense issue, that doesn't really matter. But we name a class here in the predicate term. Now what we want to do is determine whether or not this argument is valid or invalid. And in order to do that, I find it really, really helpful to figure out the form of the proposition. The form of the argument. If you can figure out the form of the argument, then you can construct your Venn diagrams. And the easiest way to do that is to figure out the middle term. And the middle term here is people who do poorly or people who did poorly. That's not really, in the first sentence I say do, and in the second one I say, and in the second premise I say did. That doesn't really affect anything on a logical level. It's just an issue of tense. So this argument, it is of the following mood and figure. It is A. You see that? A. That's the mood. And the figure is figure 2. So this is going to be really important. I say it's 2 because remember with figure 1, the middle term is the subject term of the major premise and the middle term is the predicate term of the minor premise. But notice here that the middle term, it is the predicate term of both the subject, both the major premise and the minor premise. So now that we know the mood and figure of this argument, we can construct a Venn diagram to test whether or not it is valid or it is invalid. So let's just do that very quickly and see if we can prove whether or not this is valid or invalid. Now you might be able to look at it and just have intuitions about the matter, but we need to do better than that. So we need to actually prove it. So let's construct our Venn diagram just as we've done 100 times. And before we do that, I should have already done this, but let me write out this argument. So we know that it is AAA2, so it's going to be all P R M. That's where the middle term goes, all right? The middle term goes in the predicate term of the major premise, and it goes in the predicate term of the minor premise. And then we draw our conclusion, all S R P, okay? So this is in second figure. And we're going to do just like we've done before. And we're going to diagram the first premise. So for premise number 1, I'm just going to kind of shorthand this, but all P, 3, 4, 6, and 7 are M, 1, 2, 3, and 4. We locate the regions of overlap. We can scribble that out. And we're saying all are in 3 and 4. And if they're all in 3 and 4, that means nothing is in 6 and nothing is in 7. So that's how we do the first premise. Now we come here and we're going to do premise number 2. All S, which is 2, 3, 5, and 6, are P, 3, 4, 6, 7. And what we do here is we're going to locate the regions of overlap, which, wait, I'm sorry, I said P. I knew something seemed wrong. All S are M. Oh, that would have really been bad. It's 1. We're looking at this right here, M. All S are M1, 2, 3, 4. Locate the regions of overlap, which 2 and 3, 2 and 3. scribble out the 4, scribble out the 1. We're saying all are in 2 and 3, which means none are in 5. And we've already canceled out 6, so we don't need to worry about that. Now we come to the final premise, or the conclusion, I should say, and we're going to diagram it just as we've done so many times. 1, 2, 3, 4, 5, 6, 7. And just as before, we're going to diagram the conclusion, and the conclusion S is 2, 3, 5, and 6. And P is 3, 4, 6, and 7. We locate the regions of overlap, which is 3 and 6. And we're saying all are in 3 and 6, which means none are in 2 and 5. And in order to determine whether or not this argument is valid, the regions shaded in the conclusion must also be shaded over here. 2 is shaded here and 5 is shaded here. Over here 5 is shaded, but notice 2 has not been shaded. And for that reason, this argument is invalid. As I said, you might have just been able to figure this out from your sense of things. You might have been able just to look back at it and say, hey, look, here's a counterexample. Maybe Amy did poorly because she just didn't understand the information well, in which case both premise 1 and premise 2 would be true, but the conclusion wouldn't be. But we were able to use the diagrams to actually also prove this argument is invalid using those. So that's why we use the diagrams, because I know in this case it's maybe kind of easy to see that this argument is invalid. It's maybe kind of easy to see it in this argument right here, but for some arguments it's going to be a little more complicated, and the diagrams are very, very useful for those more complicated arguments. So it's going back and forth. Turn it off. All right. Okay, so let's move on to argument number 3. Enough fuss about argument number 1. All right, amoebas are not plants because they are capable of locomotion. That just means movement, and no plant has that capacity. So I'm not going to go through every single step just the way I did in the previous one, but we're going to locate the conclusion first. And notice here we have our indicator word, because. This is a premise indicator word, and so we know what comes after is a premise. Therefore, the conclusion is the very first sentence. Amoebas are not plants. Now, this is not in standard form. And the first thing we're going to have to do is provide a quantifier. And you may think that the way to do this is to say something like this. All amoebas are not plants. This is what I oftentimes hear students say. But this is actually not correct. And it is not correct because look at it for a second. Let me move my X here. It's saying all ... are not. And this is not one of the standard ways that we write categorical propositions. Remember, we write all S are P, no S is P, some S are P, and some S are not P. There is no categorical proposition of the standard 4 that goes all S are not. We don't do it that way. So we're going to have to write this differently. We go back. This is definitely a negative sentence, and it's negative and it's universal because it's talking about all amoebas, right? And it's also saying something negative. So how do we say a universal negative? Well, we use no. No amoeba is a plant. That's how we would say it. So that's the way we would write this expression. I know it seems kind of weird because you might just say, well, all amoebas are not plants or something like that. Maybe that's what you're thinking, but that's not one of the standard 4. Now what we have to do is figure out what the major premise is, and the major term is plant. So let's look back up here and see if we see the word plant occurring where amoebas are not plants. Well, we've already used that because they are capable of locomotion, and no plant has that capacity. So that is going to be our first premise, our major premise. Now notice I have already made this into, I'll put this into standard form because I have here, the initial sentence is no plant has that capacity, but notice that's lacking our copula. And also has that capacity, that it doesn't name a class by itself, so we have to change that. And clearly when it's referring to that capacity, it's talking about locomotion. So here's how I wrote it and put it into standard form. No plant is a thing capable of locomotion. So we have our quantifier, our subject term, which names a class, our copula, and then thing capable of locomotion, that also names a class. And now we come to the minor premise, and that is just going to be all amoebas are things capable of locomotion. So here we have our argument. All the propositions are in standard form, and the argument itself is in standard form. So the next thing we want to do is figure out, is this argument valid or invalid? And the first thing we need to do is figure out the mood and figure, because this will help us to diagram the argument. And the easiest way to do that is just figure out what the middle term is. And here we see the middle term. This is clearly figure 2. And we notice that this is going to be, the mood of it is E, A, E. So E, A, E, figure 2. So what we're going to want to do is to diagram this argument. And so let me get up my trusty app here. And we're going to diagram it. EAE2. And when we have an argument EAE2, that's going to be no P is M to all S are M. Conclusion 3, no S is P. And let me just double check here and see if that's what we have here. Oh goodness. Oh, is that what we have here? Let's look at this. Man, I'm really struggling, aren't I? I was going to double check it, but I can't get all the screens to fit on here. No P is M. Yep. All S are M. No S, yep, is P. Yep, everything lines up. All right, I'm not doing that again because it's hard to get all these screens to line up. I guess if you're like more tech savvy, it'd be really easy, but since I'm not, it's very difficult. Okay, you don't care. This isn't therapy. All right, so let's diagram this bad boy. And we're going to diagram it the way that we have come to know and love. So we'll begin with premise 1, no P is M. And I could work this out and write all the numbers out, but I'm just going to kind of quickly go through this. No P is M, so what we do is we scribble this area out because we know that no P is M. Then we're going to do all S are M. Well, if all S are M, that means there's no S in 5 and there's no S in 6. All right, because they're all in M. And now we come over here and we're going to do our conclusion. And we're going to do that the same way that we've been doing them. 1, 2, 3, 4, 5, 6, 7. And no S is P. So no S is P. So here's S and here's P. No S is P. So the conclusion shaded in 3 and 6. Did we shade in 3 and 6 in the combined premises? Yes. And for that reason, this argument, it is valid. It is valid. Well, that's good to know. I know some of you were worried there for a second. All right. So number 5. Every economist understands how the markets work. But some economists advocate socialism. Some advocates of socialism therefore understand how the markets work. Now we want to first figure out what the conclusion is, and notice we have this indicator word here. So the conclusion is going to be some advocates of socialism are people who understand how the markets work. Notice that I added R down here so we'd have a copula, and then people so that we'd form a class in the predicate term. But this is in standard form now. Some, we have our quantifier, advocates of socialism, that names a class, copula, and then we have a class listed in our predicate term. Now what we need to do is figure out what our major premise is, which we're going to be looking for people who understand how the market works. Every economist understands how the markets work. Okay, well that's easy enough. Notice though that we can't use the word every because that's not one of the 4 standard quantifiers. So I've just gone ahead and skipped a step here and just changed the word every to all. All economists are people who understand how the markets work. Notice we have our quantifier here, one of our standard 4. Economists, that is a class. Economist is a class. We have our our copula here, and then people who understand how the markets work. And notice that the major term lines up in both the major premise and in the conclusion. Now all we need to do is figure out what the minor premise is. And the minor premise is going to be, but some economists advocate socialism. Now, what we're going to do here is I just went ahead and if you notice up here it says some economists advocate socialism. I added our copula here, and then I made a class here, advocates of socialism, which is our minor term. And so we have this proposition is in standard form quantifier, class named, copula, and advocates of socialism. And notice that the minor term here is the same as the minor term here. Everything is great. So what we need to do is we're going to diagram this in order to Venn diagram this in order to determine whether or not it's valid or invalid. And we need to figure out the mood and the figure just so we can have the structure of the argument before us so we can diagram it. And notice that this is going to be figure 3. So this is going to be AII 3. That is going to be the mood and the figure AII 3. And let's think about this. Okay, so let's diagram this argument. I'll pull up my trusty app here. I know it's tedious, like having to see me relaunch this every time, but there are limitations to what this thing will allow me to do. So this is AII 3, and that argument is going to be all, and since it's 3, the middle term comes right here, RP, to some, the middle term is here, RS, therefore some SRP. Now, is this a valid argument? Well, that is a wonderful question. I am so glad that you cared to ask. Well, we're going to diagram this, and we're going to begin by listing our areas and diagramming the combined conclusion. The combined premises. It doesn't make sense to diagram combined conclusion. But we're going to diagram the combined premises. And we could logically start with premise 1 or 2, but we're going to start with the first one because that has the universal quantifier. And I am going to list this out for reasons that will become apparent. But 1, 2, 3, 4, all M, 1, 2, 3, 4, are P, 3, 4, 6, and 7. We locate the regions of overlap. Now we're saying all are in 3 and 4, which means none is in 1 and none are in 2. All right, now we come to the minor premise. Some M, 1, 2, 3, 4, are S, and S is 2, 3, 5, 6. Locate the region of overlap. And we're saying some are. Since we're using the term some, we're going to be putting an X. And the X is going to be in 2 and 3. Notice we scribbled out 2, so we can't put an X there, so we're going to have to put an X right there in 3. It's the only place that it can go. Finally, we come to diagram the conclusion. And here is how we're going to do that. S, P, M, 1, 2, 3, 4, 5, 6, 7. And some S, which is 2, 3, 5, 6, are P, 3, 4, 6, 7. So we locate the regions of overlap. and we're saying some are in 3 and 6. And to do this, or to represent this, we put an X right here. Now, this argument is valid just in case the combined premises definitively put an X either in 3 or in 6. They can put it in either one. And we look over here, and lo and behold, they put an X definitively in 3. And so for that reason, this argument is indeed a valid argument. This argument is most definitely valid. And you can you can definitely just look at this and tell. This is showing that some S are P. That's in fact what that X right there demonstrates. It also shows us that some M are P, some S are M. It shows a couple of different things, but one thing it tells us is that some S are P. So this conclusion, this argument is valid. All right, let's continue right along. Number 6. Number 6 says the following: any office equipment worth buying will make workers more productive, but some computers do not do so. Some computers, therefore, are not worth buying. All right, well, the first thing we have to do is to distill this argument, and we have to figure out what the conclusion is. And look how we have this indicator term right here. Therefore. So we know that the conclusion is going to be some computers are not things worth buying. Now, if you look at what it says up here, it just says computers are not worth buying. But we have to name a class in the predicate term. So, this is, I'm going to kind of give you a heads up. We're going to actually end up changing this a little bit, but at the first pass, what we had to do is we can't just say some computers are not worth buying, because worth buying doesn't name a class. You wouldn't say it belongs to the class of worth buying. It would be things worth buying, or objects worth buying, or something else. We have to have a noun term here so that we can have a class of things. Class of things. So some, quantifier, subject term, which computers is a class. You say, well, that's a type of computer. You would say that's a type of worth buying. That doesn't make sense. That's a type of things worth buying. That makes sense. But anyways, computers, that name's a class. We have our copula here, which is are not, and then we have our class named here. Now we need to find what our major premise is, and as I've written it, things worth buying is our major term. So let's go read this. Any office equipment worth buying will make workers more productive, but some computers do not do so. Some computers, therefore, are not worth buying. Well, holy crap, we don't have the phrase things worth buying. But we do have any office equipment worth buying. So this seems like the best candidate for our major premise. And notice I've changed here any to all. All office equipment worth buying are things that will make workers more productive. So I've named a class right here in the predicate term. But in doing this and locating this as or determining this as our major premise, notice that we have a problem because the major term is not the same. We're not naming the same class in the major premise as we are in the conclusion. Office equipment worth buying, that is not the same thing as things worth buying. Things worth buying is a broader class. I mean, you could, in the class of things worth buying, I don't know, that could include cars, it could include home televisions, it could include blenders. I mean, things is really broad. So what we have to do is, if we're having an argument, if it even has a chance of being a good, valid argument, we have to name the same class of things here as we do down here. The major term has to be consistently stated in the major premise and in the conclusion. So we're going to have to change one of these, reword it. Either we're going to have to reword this down here or reword what we're saying in the major premise. And what I say we do is we reword what we're saying in the conclusion, because I just supplied the word things right here. This was not given. Office equipment is a term that was given. So just to make the argument consistent, we should reword it as follows. Some computers are not office equipment worth buying. Now notice that our major term is consistent here and it is consistent down here. So we are naming the same class of things in both this proposition and in the conclusion down here. Now what we need to do is locate the minor premise, and that is going to be some computers are not things that will make workers more productive. So here you notice because if we look back up here, some computers do not do so. I'm just supplying what it's saying there in a more truncated way. I'm just spelling it out here. But some computers are not things that will make workers more productive. Now that we have the argument, it's laid out in standard form, what we want to do is to determine if it's valid or invalid. And we need to figure out what the mood of the argument is. And the mood is going to be A, and then some not, which is O, A, O, some not, which is O, A, O, O. And we need to know the figure. And the figure is going to be figure 2. Notice that things worth buying is the middle term. Things that will make workers more productive is the middle term. It's in the predicate term in the first premise. It's in the predicate term in the minor premise. So this is going to be A, O, O, 2. And we're going to diagram this argument, and we're going to diagram it. Let me pull up my app here. It'll just take a second as always. We're going to what am I doing? Diagram this argument. A002. So it's going to be all P R M, some S R not M, therefore some S R not P. Well, is this a valid argument? I don't know. It's hard to say, isn't it? Let's see. Whoa. Two, three, four, 5, 6, 7. So we're going to begin by diagramming the combined premises, and we'll start with premise 1 because it has the universal quantifier in it. All P, which is 3, 4, 6, and 7, are M, 1, 2, 3, 4. Locate the regions of overlap, cross those out. All are in 3 and 4, which means none are where? 6, none are in 7. Now we come to the second premise. Some S, 2, 3, 5, and 6 are not M, 3, 4. Whoa, what am I doing here? 1, 2, 3, 4. We locate the regions of overlap, 2 and 3, 2 and 3. And we're saying some are not. Notice that word, not there. And not in 2 and 3, which means they're in 5 and 6. Now, here's the thing. We've said that 6 is empty, so we can't put anything in 6. So this is where we have to put our X because we've already shaded in 6. So we can't put anything there. And now finally we come to our conclusion, and we diagram our conclusion just as we've diagrammed everything else. 1, 2, 3. All right, forget the 3, 4, 5, 6, 7. Come back to the 3. There we go. All right, and some S, I'm running out of room here, people. Some S, which is 2, 3, 5, and 6, are not P. P is 3, 4, 6, and 7. We locate the regions of overlap, which is 6 and 7. We're saying are not in 3 and 6. So if they're not in 3 and 6, we put an X right here over 2 and 5 because that's where it would go. And this argument is valid just in case the combined premises definitively put an X either in 2 or 5. And look over here. Lo and behold, it definitively puts an X in 5. And for that reason, this is a valid argument. It's a valid argument. Now we come to problem number 8. And this one I found really interesting for a couple of reasons, but primarily because it combines a number of the skills that we've learned throughout the semester. But let's look at this. Those who supported the voting rights bill were opposed to racial discrimination. So conservatives who did not support the bill do not oppose discrimination. Well, the first thing we need to do is we need to figure out what the conclusion of this argument is. And notice here that we have an indicator word, so. And this tells us that the conclusion is occurring in the last sentence. However, the issue here is that this is also providing us a premise. The conclusion is not, this entire last sentence, conservatives who do not support the bill do not oppose discrimination. This includes both a premise and it includes the conclusion. And the conclusion seems to be conservatives do not oppose discrimination. Now this provides actually a really interesting problem here because we need to figure out what the quantifier is. You notice down here we don't have a unit or a quantifier mentioned at all. And we could, in theory, have two different kinds of quantifiers. We could either have a universal quantifier or we could have a particular. Now what difference does that make? Well, that difference is going to be if it's particular, we're only talking about some conservatives. So, if you imagine, I don't know, let's say, I don't need to go into it, but just let's say, when I say some, it could be that half of them didn't support the voting rights bill. Or it could be universal. Am I talking about every single one? Every person who's a conservative, did none of them support the bill? And this is actually kind of interesting, and you may recall we talked about restrictive and non-restrictive clauses a long time ago, where when I say something like Japanese who eat a lot of fish are healthier versus Japanese who eat a lot of fish are healthier. And you may or may not recall that when we offset something in commas like that, it actually changes the meaning of what you're saying. If I say Japanese who eat a lot of fish are healthier, well then that is a restrictive clause. I'm restricting what I'm saying. I'm talking about specifically those who eat a lot of fish. But if I say the Japanese who eat a lot of fish are healthier, I'm talking about all Japanese in that case. So if we look in this sentence right here, you'll notice we have a non-restrictive clause who did not support the bill. It's set off in commas here. So it seems to me that this is universal in nature. It's talking about all conservatives. And what this is claiming is all conservatives did not oppose discrimination. So you may think that this is the correct way of writing this. All conservatives are not people who oppose discrimination. And if you were to think this, you would be incorrect. And the reason for that is this is not one of the standard 4 ways that we write categorical propositions. We don't say all not. Instead, if we're making a universal negation, what we do is we write it this way. No conservative is a person who opposed discrimination. Remember, this is universal, it's also negative, and we just use the word no. That's all we need. Now what we need to do is we need to figure out the major premise. And we look down here at the major term, which is person who opposed discrimination. Those who supported the voting rights bill were opposed to racial discrimination. Well, there we go. All people who supported the voting rights bill are people who oppose racial discrimination. Now this is just one little minor detail, but it is important to point out. Notice that the major term is not the same in the major premise and in the conclusion. Down here, the class of people I'm naming are people who oppose racial discrimination. Down here, people who oppose discrimination. These are technically not the same because the class of, people who oppose discrimination, that's going to be broader than racial discrimination. When we talk about discrimination, you could, if it's just saying discrimination generally, we could discriminate for reasons of religion or sexual orientation or whatever, right? Racial discrimination is a particular kind of more general forms of discrimination. So just to make sure that we are naming the same class of things in the major premise and in the conclusion, we need to just add the word racial down here in the conclusion. It's really, not it's not a very complicated procedure, but this ensures that we're naming the same class of things up here as we're talking about down here, and it keeps our argument and our language consistent. So now that we have that, we come to our next issue, which is identifying the minor premise. conservatives did not support the voting rights bill. Now we have the same issue that occurred here when we were trying to figure out what the conclusion was, which is that we need to determine, are we using a universal or a particular quantifier? And for the same reasons I mentioned earlier, I think we're using a universal quantifier. We're talking about conservatives who did not support the bill. We're talking about all of them. But we don't say all conservatives are not people who supported the bill. When we're making a universal negation, what we do is we do it this way. No conservative is a person who supported the voting rights bill. Now that we have this figured out, and this is the argument in standard form, notice that I have named classes and all my subject terms and all my predicate terms, and I have all the propositions are in standard form, the argument is in standard form. What we need to do is figure out the mood and the figure. And the mood of this is A, E, E, and then the figure is going to be, let's look at this. We have our middle term is people who supported the voting rights bill. I should have, that word bill should be in red, but it doesn't really matter. Anyways, that's going to be the subject term here, and it's the predicate term in the minor premise. So this is figure 1. So let's diagram this argument, and we can see whether or not this is valid or not. I don't know. What do you think? You think it's valid? I know you're hanging on the edge of your seat, aren't you? Well, if it's AAE1, it's going to be all, if it's 1, MRP. And remember, when we do figure 1, it goes from right here to right here. No S is M, and then we're going to do no S is P. And in order to determine whether or not this is valid, we come up with our trusty diagram here. And we diagram the combined premises. Whoa, getting carried away there. Diagram them. We could start wherever we want it. We could start with since we have universal quantifiers in both the minor premise and the major premise, we could in theory start with either one. It doesn't matter. But I'm just going to start with the first one because it seems the easiest. All M are P. All M are P. Well, if all M are P, that means all M is in region 3 and 4. And if they're all in 3 and 4, that means none are in 2, no M are in 2, and no M are in 1. Then we come down here to the second premise. No S is M. Well, if no S is in M, then that means no S is in 2 or 3, so we would cross that out, and all S are in 5 and 6. But no S is M. That's what we have shown here. And all M are P, all M are there. So now we come to, I feel like when we have these ones with universals, quantifiers, it's a little bit easier just to kind of breeze through them. But if I'm going too quickly, shoot me an email and I can do it more slowly for you. 5, 6, 7. And then no S is P. Well, how do we show that? Well, we cross out 6 and we cross out 3. Just like that. And what this shows us is that what we had here is we have these two regions right here shaded. And because these two regions are shaded here, they need to be shaded in the combined premises. But notice they're not. And for that reason, this argument is invalid. It's invalid. Well, actually, right now, you're just learning how to spot validity and invalidity. Next lecture, you're actually going to learn the reasons behind why it's invalid. We're going to learn that in some detail. So this argument is also, this is invalid. It did not shade in the same regions. The regions that were shaded in the conclusion were not shaded in the combined premises. So, all right, I think we're on our last argument now. So you guys are in the home stretch. This one was my favorite one to do. I know some of you, you don't have fun doing any of this, but to me this is kind of cool. So, no job providing health care benefits is unacceptable to me, but some white-collar jobs do not provide such benefits. So some white-collar jobs are not acceptable to me. Well, we have to distill this argument first, and we'll do that by figuring out what the conclusion is. And lo and behold, we have our indicator word right there, so. So the conclusion is going to be some white-collar jobs are not acceptable jobs to me. Now, you know, if you look up here, I added not acceptable. Dang it, I have a typo here. That shouldn't be acceptable to jobs to me. It just should say acceptable jobs to me. So sorry about my typo here. But if you look up here, it says not acceptable to me. Acceptable to me does not name a class. You want to say that belongs to the class of acceptable to me. The class is going to be, excusing my typo here, acceptable jobs to me. So I did make that one modification so that we would have this proposition in standard form. Quantifier, class, copula, class. All right, well, next thing we have to do is we have to figure out what the major premise is. And the major premise seems to be the very first premise. No job providing healthcare benefits is an unacceptable job to me. But notice that we run into an immediate problem. Our major term is not the same in our conclusion and in our major premise. In fact, hopefully you recall that what we have here is we have class complements of one another. Up here in the major premise we have unacceptable job. Down here we have acceptable job to me. These are complements of one another. And so, I mean, if you're saying, well, there are two classes of things, the class of jobs that are acceptable to me, the class of jobs that are not acceptable or unacceptable to me. These are not the same. They're just different classes. So we have to have our major term align in our major premise with our conclusion, or we're going to be reasoning in an invalid way to begin with if we're just not talking about the same exact things. So we have to modify one of these two statements. And you know, the easiest way to do that is just so that we get our major terms to align, is just to take the obverse of one of them. And I'm going to just go ahead and take the obverse of the major premise just because, I don't know, just pick that one. We could have taken the obverse, I suppose, of the conclusion. I think it would work out just the same. You might wonder, well, why not take the contrapositive? Because isn't the contrapositive also a logical equivalent to this? If we were to do the contrapositive, though, you might recall that would not only affect the predicate term, but it would actually affect the subject term too. We'd be finding the complement of the subject term, which would then throw off our middle term, because then we'd have the complement listed in the subject term in our major premise of what we say down here in our minor premise. So taking the obverse is just the easiest thing to do. Now, what's the obverse of premise 1? Well, in order to find the obverse, the first thing you do is you change the quality of the proposition. So this is a negative proposition. We see no, so we're going to change it to an affirmative, all. And then we find the class complement of what is stated in the predicate term. And the class complement of unacceptable job to me would be acceptable job to me. So here is the obverse. All jobs providing healthcare benefits, I should say, are acceptable jobs to me. So typo machine today. All right, so the obverse of, go back a slide, the obverse of this proposition is this. And the obverse, you might remember, in all cases, the obverse is always logically equivalent. So that would work. Actually, we couldn't have taken the contrapositive. I'm sorry, because why? Because the contrapositive of universal negation is not logically equivalent. So that's another reason it's good to work with obversion, because obversion always works. The obverse is always logically equivalent. So lastly, we need to find the minor premise, and the minor premise is going to be some white-collar jobs are not jobs providing health care benefits. Now, that we have this figured out, this argument is in standard form, barring some of my little typos that I have up here. We need to figure out what the mood and figure are. And the mood and figure of this is going to be A, let's see, O, and then what is the figure? Well, we got to locate the middle term, jobs providing health. That is going to be 1, A-O-O-1. So let's diagram this argument and see whether or not it is a valid argument. All right, so A001, and it's going to be all MRP some S are not M, therefore some S are not P. Is that right? That seems like I did something wrong. Hold on, sorry. Yeah, that's right. It's 100% right. Okay, sorry I had to double check really quickly. All right, so let's diagram this and see how we do. Is this argument valid? That is a fantastic question. All right, so S, M, and P, 1, 2, 3, 4, 5, 6, 7. Okay, so let's begin with the first premise because it's a universal, so it tells us the most definitive information. All M is 1, 2, 3, 4, P, 3, 4, 6, 7. Locate the regions of overlap, scribble that out. All are in 3 and 4. Well, if they're all in 3 and 4, where are they not? Nothing in 1, nothing in 2. All right. Now we come to second premise. Some S is 2, 3, 5, and 6, are not M. 1, 2, 3, 4. Locate the regions of overlap, 2 and 3, 2 and 3. They are not. That's very important to point out. So if they are not M, did we do that right? 2, 3, 5, 6, 1, 2, 3, 4, 2 and 3. 2. Okay, so if they're not M, where are they located? What are they? It's going to be in 5 and 6, all right? Because it's are not. Now we come to the conclusion, and let's diagram that. S, P, M, 1, 2, 3, 4, 5, 6, 7. Some S is 2, 3, 5, 6, are not P. P is 3, 4, 6, and 7. Locate the regions of overlap. So some are not in 3 and 6, which means they are where? 2 and 5. And in order for an argument to be valid, it has to definitively place an X in either region 2 or region 5. Does it do that over here? No, it does not. And because it does not, this argument is invalid. Well, that's it for this homework assignment. I hope that you're starting to get a better sense of how to do this. Notice how many skills we're combining at this point. You know, we had to even go back and dig a little deeply and figure out or see the restrictive clauses, which we've talked about in the past. All of this stuff is building on the previous information that we've been discussing in here. We begin by distilling an argument. We put the propositions into standard form. We have to, in some cases, go back and figure out, well, is this a restrictive clause or non-restrictive clause? We have to figure out the class complement and take the obverse of a proposition in order to put it into standard form, because that's necessary in order to figure out the mood and figure so that we can then diagram it. So it's important to stay up on all the information we're covering because it just keeps building and building and building on itself.